All right, we're on our last little itty bitty portion of a question for chapter 8, but it's not itty bitty in terms of concept. So it's a really big deal because it's going to set up the rest of the course. So we had just found this. We had just found, suppose you wanted to know the chances of getting a random group of 40 pennies, to have an average that was 16 years or more. And we found that the chances of that were 0.0076. So suppose you actually did get a batch of 40 pennies and they had a mean age greater than 16 years. What are some conclusions you could reach? Okay, so I did this problem already, but the video gave out on me, so bear with me because I'm going to reveal the answers one by one here. First one, it's possible that you took a biased sample or a not random sample. Maybe you thought you were getting somebody's random coins, but that person was actually a coin collector who's into old coins, or they knew what you were doing, and so they set you up like magicians often do. Like, oh, you think this is random, but it wasn't really. So possible the sample's not biased. Now, or excuse me, the sample is biased, not unbiased. That's a big deal from chapter 1, and it's kind of laying the foundations for everything we do for the rest of the course. We're always assuming random and unbiased, which is, of course, in real life kind of hard to come by, but we're going to assume it nonetheless. Now, there's another option. Suppose it happens by accident. It was a fluke. Okay, you just happened to get an old sample. Now, the chances of that are what you actually calculated here using the stuff we know from chapter 7 and 8. It's 0.0076. So it's possible to get 40 pennies to have an average of 16 years or older. But the chances of it is less than 1%, 0.0076. So it could happen, but it's not very likely. Okay, so if we say these two are off the table, you say, like, look, I know I took a random sample. It was totally not biased. Doesn't really happen very much in real life, but, whatever. So pretend that you knew that. And then you say, look, that chances of that is just so low. I'm not willing to buy that it's a fluke. I think something else is more likely. And that leaves us to the third option, the big kahuna. Maybe it's not really that the average is 12.2 anymore. Maybe things have changed. So maybe the mean isn't 12.2, the standard deviation is not 9.9, or both. Maybe people are hoarding coins now. Maybe, I don't know, copper's become precious. Maybe there's some comic book supervillain who's hoarding all the pennies, and that leaves all the rest of us with young pennies. Who knows, right? Some part of to take over the world. It's kind of thing Megamind would do, right? All right, so if that's the case, maybe these parameters of 12.2 for the mean and 9.9 for the standard deviation aren't true anymore. That could totally happen. And this sample of 40 pennies kind of gives us evidence that this is the case. If we knew that we took a random sample, so we know it's not biased, and we're not willing to buy that it's a fluke because the chances of it are so low, then maybe this is more likely, that something's gone on, something's changed, something's happened. And that right there, that thing I just highlighted, that's kind of the basis for chapters 10, 11, 12, and 13. If things don't work out like you expect them to, or they have a really low chance of happening, then maybe it's something else that's going on instead. And that's what we're going to use hypothesis testing for. All right, we are done with section 8.1. I will see you back here for 8.2.